Drought avoidance. I hope you can read that. I apologize for the small print. But different mechanisms associated with drought avoidance: increased water uptake. If we can just increase that root mass. And we make great strides there just in the way that we farm. Again, with our strip till and minimum tillage practices. Trying to get those roots deeper, trying to get a bigger, more robust root system out there so it's better able to go mine and look for this water. In decreasing water loss, if we can do something to reduce the transpiration rates. And, used to when I would walk corn plots, and I know Robert's the same way, we go through and evaluating new hybrids that are coming through the pipeline, and I take my notes and I note those ones that just rolled up and turned blue in the heat of the day. And I always considered that a bad thing. But it's not necessarily a bad thing. It's a defensive mechanism. And sometimes some of those corns would be the ones that we'd advance. They didn't look that cool in the field, but they really produced because they were able to protect themselves in the heat of the day. So a lot of different factors, as I said, that you have to consider when you talk about this thing we call drought. Drought tolerance. A lot of the things that happen inside the plant cells and inside the plant system itself, osmotic adjustments and cell wall elasticity and cuticle thickness and all these other things that the gene jockeys have got figured out way more than I do. But it's exterior influences on that plant, and it's also things within the plant itself that we maybe can improve upon. We can just make that cell wall a little more elastic where it will give and take and can handle some of the stresses in the heat of the day. So again, I hope you appreciate the fact that there's a lot going on in this corn plant and the environment that we call drought. So looking at these different plant processes and these different mechanisms, let's get into it, and briefly I'll tell you what Monsanto's doing with this drought gene, what it looks like, and how we think it's going to benefit producers. In all honesty, the first drought gene that we release is probably, it's not going to be the best fit for this part of the world. Okay, it's going to fit the I states, going to fit them better. And there's a lot of reasons behind that. And I always get ticked when I go to, I'm the only Monsanto guy in here, I hope. I always get ticked when I go to St. Louis and I hear those guys, my counterparts in those I states, and I think, man, we're an I state too. It's called irrigation. And you guys need to remember us. I want to assure you that they are remembering us, and we're going to get there. When you just look at the production and the potential of this area, no one ignores it. But the first gene is probably going to fit the Iowa farmer better than it will us. So if you look at this, how does this drought tolerance work in a corn plant? And again, I apologize for this review for most folks, but if you look at just the different things that the plant itself is going to do to try to survive in the environment, and just the structure of that plant and the environmental stresses that are put on that plant, how is it affected? Primarily, the two things we're interested in is just plant biomass, how much plant's out there, and then how much grain are we going to have? What's it going to produce in the end? So if we can control some of these internal reactions of the plant to the environment, then the outcome should be increased yield either in the forage or fodder. And again, a review just some of the most critical times in the growth of corn planting. That reproductive stage from silking to maturity. We all understand if we don't have water, that plant's going to be stressed. We don't want it stressed in those critical times. Get this click. If you just look at the potential loss per day, if that corn plant is just stressed, at the 10-leaf stage, you can lose 1 to 2%. Obviously, we all understand that reproductive silking and tasseling stage, that's your dramatic yield loss potential is right there. And we always want to make sure we've got good water underneath those plants when we enter those stages, and then all the way through grain fill and to black layer. So these are the most critical times for a corn plant as far as potential loss of yield or in this area here. And I like to remind ourselves that, when you buy that corn seed or cotton seed or wheat or whatever, when you buy that seed and spend the big dollars for that seed, its genetic potential, its yield potential is already set. From that point, when you put that seed in the ground, the only way that yield can go from that point on is down. You know, that seed has got all that God's ever going to allow that thing to make. So if you've got a corn seed, genetically, if we could take that gene out and spread it out on the table and look at it and dissect it and understand it, it would tell us that corn seed has a yield potential of 500 bushel. But everything that happens to it from that point on just reduces that. So all of these things, whether it's drought tolerance, whether it's insect tolerance, whatever it is trying to reduce the impact of the environment on that plant. Again, just another way to look at it, percent yield loss across time. When these plants are planted, 4 to 5 leaf and all the way out to maturity. Again, we're reminded that this curve, you know, right here at grain fill, really becomes critical to tasseling and reproduction and at grain fill. This is when we want to make sure that those plants are stressed. However, and we all understand this, if they're stressed early on, you're setting the tone. You know, like I said, when you plant that seed, it's already set. The only thing that can happen is negative from that point on. So, you know, we want to keep them pre-water. We want to get those plants started off good, so that when they hit that critical time, they've got a good root mass and they're healthy and they're not stressed by other factors. So the drought gene, this is the way that Monsanto codes our technologies. So it's 87460 is the D1 gene. And the first steps, well, I'll back up just a little bit. It's going to be the first gene, the first trait that we're going to introduce to address drought in particular. We hope to have this thing commercial in this next decade, sometimes in the teens here, depending on which St. Louis guy is standing up here and talking to you as to what date we think that we'll launch that. But it's coming. It's almost here, guys, and it's going to be fun to watch when it gets here. But this trait is specifically designed to look at yield efficiency. We're evaluating the economic benefits of it. We're looking at some very, very stressful environments in the Western Corn Belt. I'll say that for the next slide. Okay, how does this gene work? And the gene jockeys have named this thing CSPB. That's the actual gene. You might write that down in case somebody ever asks you, you know what it is. But what does it do? In 756 trials the last couple of years, we've been able to see a growth rate increase with the gene of 3.6%. Okay, so the plants without the gene growing normally in that environment, and with the gene, we've increased our growth rate by 3.6%. Chlorophyll content was increased to 0.5%. Photosynthetic rate 3.6. So you can see the gene is actually doing something. We're really tickled that we've got a gene that's just actually doing what we hoped it would. I know it's difficult to see from the back of the room, but you know, here's the row of corn without the gene. And in these trials, again, very limited water, very stressful environment. We're producing 76 bushel per acre. With the gene, we were able to increase that to 94 bushel per acre. So we're getting a significant increase in both biomass and yield of these plants. And again, we're getting more kernels per plant, and we're seeing the things that we wanted to see with it. There were probably, I don't know how many they started with, but probably 6 candidate genes that we were looking at 5 years ago when they whittled them down to just one that we're going to go with first. So again, some more pictures of the same thing. These same ears of corn, I think you can see a little better on this picture. But without the gene and with the gene. And this was showcased and really made public this year at the Farm Progress Show.